Hello. This will be a demonstration of Proposition 27 from Book 9 of Euclid's Elements, which says that the difference of an odd number from an even number is odd. Or in other words, an odd number minus an even number makes another odd number. We're given two numbers, AB and BC. The first of which, AB, is odd, and the second of which, BC, is even. And what we want to prove is that AB minus BC, that is the number CA, that this number CA is an odd number. We're going to begin by taking a unit away from our number AB. So we're going to have the number AB minus the unit AD make the number DB. And because the number AB is an odd number, we were given that. We know from definition 7.7 that if we take a unit away from an odd number, we'll always end up with an even number. So that because we've taken the unit AD from the odd number AB, the remainder, which is the number DB, will therefore be an even number. But we also know that the number BC is an even number. We were also given that. So if we take their difference, if we do BC minus DB, we'll end up with the number CD. And Proposition 9.24 says that an even number minus an even number makes yet another even number. So that because BC and DB are both even, their difference, which is the number CD, is also even as well. We're finally going to add the unit AD back onto CD. And we know that this will produce an odd number. For again, from definition 7.7, the definition of an odd number, we know that an odd number is always one away from an even number. So if we add a unit onto an even number, we'll get an odd number. So that the even number CD plus the unit AD will make the number CA odd. And this is what we set out to prove. We set out to prove that the number CA is an odd number. So we are therefore done with the proposition. Therefore, etc. QED. This is the last proposition where Euclid deals with taking the difference and how even and odd number differences relate to each other and what sort of numbers they'll produce. So say, as an example, we have the odd number 9, and we subtract from it the even number 4. What we're going to end up with is the number 5. And what this proposition 9.27 tells us is that this number 5, which is the difference of an odd number from an even number, will be odd itself. The way Euclid goes about proving this is he takes a unit away from our number 9, or another way to put that is that he rewrites 9 as 8 plus 1. If we subtract 4 from that, we'll still get 5 because we haven't changed any of the numbers here. His next move then is to rearrange this and say that 8 minus 4 plus 1, that will still equal 5. 8 minus 4, we know that's going to be an even number. Because we know from Proposition 9.24 that an even number minus an even number makes yet another even number. So 8 and 4 both being even numbers will therefore have their difference be even as well. So if we add the unit 1 back onto that even number, we'll get the number 5, which this proposition confirms for us. It is an odd number. 4 plus 1 is 5, and that's 1 above an even number, so it'll make the odd number 5. That's all I've got to say about this proposition, so I'll end the video here and move on to Proposition 9.28.